Welcome everyone to this our 12th episode of EV Society's Canada Talks Electric Cars webinar. My name's Tim Burrows and I'm going to be the moderator once again for today's webinar. Electric Vehicle Society, as many of you know, is a national organization and we welcome members, new members at just $30 a year, $20 a year if you're a senior like me, and free as an associate member. Come and join us for a virtual meeting held every month, and you can just visit the evsociety.ca website for more information. I'm going to remind you that this webinar is being recorded and it will be posted on our YouTube channel for later viewing. Today's webinar, as usual, will run no longer than 60 minutes. All guests have joined the webinar with their cameras off and their microphones muted. You're encouraged to ask our guest speaker questions at any time using the webinar's Q&A function. And remember, please, that you may upvote other people's questions if it's something you'd like to hear answered, and that'll put it in priority as we go through those questions at the end of the presentation. Jason Arnaud is back again to take us through those questions, and that will happen immediately following the presentation. Today's webinar, Recycling Lithium-Ion Batteries in the Supply Chain of Critical Materials, will be presented by Ajay Kochhar. He is President and CEO, Co-founder and Executive Director of Li-Cycle. He's responsible for strategic oversight of Li-Cycle's various functional business units, which includes commercial, technical, that's health, safety, environment, and quality operations, commercialization, and research and development. Additionally, Ajay supports the development of international growth initiatives for the company. Before founding Li-Cycle, Ajay gained extensive technology and project development experience through progressive roles with Hatch's industrial clean tech and advisory practices. While working in that space, he garnered in-depth engineering and project management experience through clean technology development in the rare earth metals industry. His technical expertise spans the entire project lifecycle, from conceptual and pre-feasibility studies to construction and commissioning. Born and raised in Greater Toronto area, Ajay comes from an entrepreneurial roots, having gained experience from a young age via a family business. An ardent music fan and music enthusiast, he is a classical guitarist who maintains the hobby even now for enjoyment. Ajay is a graduate of the University of Toronto and holds a Bachelor of Applied Science in Chemical Engineering. Hey Ajay, on with the mic and the camera. Welcome to Canada Talks Electric Cars webinar.
Yeah, pleasure to be here. Thanks for having me and having Li-Cycle.
Oh, it's fantastic. You know, those of us who are fortunate enough to be driving electric cars, we're accustomed to answering a similar set of questions from people who are new to it. And one of those questions is invariably having to do with battery disposal and, you know, the landfills. And so we're really looking forward to hearing the presentation and finding out what Li-Cycle is all about. So it's my pleasure. I'm going to turn the microphone and the screen over to you.
Perfect. And the answer there is no landfilling of batteries, electric vehicle batteries. And that will be the resounding message in the close here. And maybe to take a step back before I launch in, and thanks very much for the kind introduction there. So we're going to take maybe the next 30-ish plus minutes. We'll see as we go in terms of the content. And what I want to do today is talk about what we do as a business, Li-Cycle, and we are a commercial lithium-ion battery recycling company. We'll talk all about where we are and where we're going, but just to get launching off of that common misnomer of the ominous end of life of lithium-ion batteries and going into landfill, that is something I can resoundingly say will not happen from both economic and environmental perspectives. And it's really where our business is centered, and that's what we do. So we're going to be talking all about that for everything from, and just to jump into the slides here, everything through from who Li-Cycle is, where are we going, some macro context as well around this industry with respect to lithium-ion battery recycling. What's the growth that we're seeing, you say, in lockstep with electric vehicle and lithium-ion battery proliferation, and the very logical end of life tsunami that will come of batteries from electric vehicles, but also from all types of applications of lithium-ion batteries. So just to start with, the highest level of who we are as a company, and before maybe I just step into the slides, I'll give you a bit of the story of where we come from. So as you heard in the intro there, I'm a chemical engineer by background. Tim Johnston, my fellow co-founder, and I founded this business in 2016. And we were working prior to that, as you heard, at a firm named Hatch. Tim was also at Hatch with me, and so we got to know each other. And Hatch is a global engineering, procurement, construction management firm. And we were working in the lithium-ion battery chemical space. So what we were doing was engineering, delivering, building plants for clients and partners that make the chemicals that go into battery materials and then into EVs and other applications, in battery cells. So, for us, seeing the rapid growth and change in this industry over 5 years, 10 years, in a very relatively short period of time, we were always wondering, and also constantly getting asked, okay, well, maybe we're making lithium, for example, as a chemical. We would get asked by clients saying, what's going to happen though? We're all supplying these critical materials in these refined forms into the battery supply chain. What's going to happen here in terms of all of these end-of-life batteries? And it's not only end-of-life batteries, and one thing that will come out again later on when I talk about the market, it's also, as you make battery cells or all along the supply chain, there's various types of waste that also are production scrap. And that's just like any manufacturing process. No manufacturing process is perfect. And that's not a huge percentage of the output typically of a factory for batteries. But when you start thinking about, in our world today, there's over 200 battery megafactories in the pipeline. And when we started Lifecycle in 2016, there were just over 10. So I can see that again, over 200 megafactories for batteries to be produced. That in itself generates a lot of production waste. So the point there is, this is not an industry that grows solely at lag with EVs and proliferation. In actuality, we have to grow in lockstep. And there's two phases of growth here. One is proliferation of lithium-ion batteries, EVs, and the manufacturing scrap that's produced, and also already dealing with consumer electronics. And phase two of the growth of this industry is really around the end of life of lithium-ion batteries. So I say all that to tell you a little bit of the story about where we come from, but it also goes right to the heart of, well, why do this now, right? When we started this company, we would often get told, hey, Ajay and Tim, what are you doing? Isn't this a problem for 10 years from now? But we knew that it wasn't, and we knew we needed time to develop. And hence here we are today, over 100 people, commercial business. We're the largest lithium-ion battery recycler in North America, and we're really just getting started. So I wanted to start there verbally before I start going through slides and a lot of information. And everything I've just said is really reflected in our vision and mission. And we're really doing this ultimately for the greater good of the planet, but the core of our ethos is sustainability. And people say, well, sustainability, from an environmental perspective, that's very logical. But inherent to the word sustainability is also sustainably profitable and economically sustainable. And that is very much part of our ethos here, is make lithium-ion battery recycling self-sufficient from an economic perspective and profitable, so that when we set out to do this, we said, oh, hey, we don't want subsidies to help to make this happen. The business needs to make self on its own. So more on that to come, but you see that intent very clear and purposeful in our vision and mission. So a lot of things I said in the opening will now come into the detail in the slides. And this here is just a bit of a NASCAR slide, if you will, of different things that we're proud of and recognition that we've been bestowed with, and very proud of what the team's done so far. See at the bottom in terms of recognition, and just a little bit of the milestones that we've accomplished and achieved, and then what's coming. And really here, I'm going to talk about the way that we approach lithium-ion battery recycling, what the technology is. You're going to hear this recurring theme of spoke and hub. So I'm going to explain what that means in a bit. But the point here is that we are commercial. We're doing this today. We have over 50 battery supply customers today. That keeps going up, keeps growing. We make product, we sell product. I'll talk about where that goes. So we're really now in the scaling mode. But in many ways, as you're going to see in the market information I'll share later, really just getting going here in terms of the industry. So let's take a step back and I'm cognizant that maybe some folks are very familiar with lithium-ion batteries and some others who may be listening are not. And I think just to help paint the picture, the rechargeable lithium-ion battery, the same technology that is in our smartphones and the same technology, say original base that was commercialized by Sony in 1991, is the source of the continued evolution and innovation that has occurred and enabled lithium-ion batteries to drive mobility and drive, now as we get into future-facing revolutionary changes in batteries as well, still lithium-based, that is going to drive things like flying taxis. And that sounds perhaps a little far off and a little crazy, but this is where the world is going, and it is enabled by the same underpinning core technology that is lithium-based. And this page here is basically depicting the relative growth in the manufacturing or the demand of lithium-ion battery needs in gigawatt hours, which is an energy term per year. So you can see here in a short 20 years, relatively, you have massive growth in the demand for lithium-ion batteries. And what's enabled that, it's a bit of a positive feedback loop, is decreasing cost, better technology, continued innovation, and driving at what consumers want, right? In terms of a car, for example, better range, as well, lighter, more compact, etc. And as that continues to advance, it's enabling more technology, which enables more demand, which causes the need for more lithium-ion batteries. So that's what's been happening in the past, now going on close to 30 years since the first commercialization. But it's, again, just getting started. And this affects our growth and how we need to scale. And we have a team that just looks at this. And the punchline is that we have to continuously upward revise our projections and see, okay, well, how do we continue to grow as nimbly as possible that we can? But all that said, I think as I opened, this has been the perennial question, right? Is, okay, well, what's going to happen though when all that production is done? And it's not only end-of-life batteries, this tsunami of end-of-life batteries. That's what I called phase 2. It's also about phase 1 of, again, as you make batteries and the supply chain scales, it's not perfect, you have waste. Where does that go? And what's the infrastructure to deal with it? So to help put some numbers to this and look semi like a tsunami visually, this is a projection which has been based on independent inputs, and there's a variety of projections out there. We actually have one of our teams, our corporate development team, this is one of the things that they maintain as our total addressable market forecast. Okay, so let me just explain what this is. So this is a projection of the total lithium-ion batteries available for recycling in tons per year. And this is, in the sense of lithium-ion battery material. So it could be everything up to a pack. Imagine a pack out of an electric vehicle that you folks know and drive, all the way down to lithium-ion battery materials. So when you're making lithium-ion batteries, you have waste. And I'm going to explain here what the different segments are. And that could be full battery cells. It could be all the way down to constituent materials. So what do you see here? Well, what you see is 2020, you see close to 500,000 tons. It's precisely 465,000 tons of lithium-ion batteries that need to be recycled. or needed to be recycled and are available for recycling in 2020. And by 2030, in the period of the decade, you see that growth all the way to 2.6 million tons of lithium ion batteries and materials needing recycling. So that is massive growth in the recycling need. And to help just dive a little deeper and speak to this phase 1-2 growth I was talking about and just help to explain that, if you look at the bottom of the graph, you see here these different annotations: manufacturing scrap, you see transportation, energy storage systems, and consumer electronics. Just explain what that is. Manufacturing scrap is the waste from, as I was talking about, the manufacturing of batteries. So as you go along the line of making a cell through to a module, through to a pack, it's not perfect. You have offcuts, you have quality rejects. That's typically 5 to 10% of the output of a given manufacturer. And that's a very good rate. Actually, that's a reject, I'd say quite a optimal reject rate. Sometimes we see more, depending on the year of startup. Early on, they're trying to tune a process, more scrap. If it's a perhaps lower quality battery manufacturer, you can have a higher scrap rate, et cetera. So there's a number of things that affect that, but we use a 5 to 10% conservative rate in our figures just to be more conservative. And just to help illustrate that point, well, what do you see? On the left of the graph, you see a very big blue portion, this medium blue portion of the tonnage, and that is manufacturing scrap. And again, as I said, 200 mega factories for making batteries that are in the pipeline and coming just to meet this demand. Well, that's growing lockstep with proliferation of EVs, right? And the point there is that doesn't wait till electric vehicles die and come out to be recycled. The gray portion is the end of life part of transportation, so e-mobility, electrified mobility. What you see there is that actually doesn't really become that significant till, as you see, 2030. So what's the point here? The point is that, again, recycling is not a problem or an opportunity for 10 years away. It is actually something that is very much here today. And this is what's enabling us to set up the infrastructure for the future when there will be a much greater quantity of lithium batteries that need to be recycled. So this is just a bit of a different view of that. This is the contained material that can be recovered from lithium ion batteries needing to be recycled. And these are just key critical materials, not all of them, but just a few of the critical materials. And critical material being materials that are really essential for our economy, for from a national defense standpoint, et cetera. And what you see here is the tonnage of that material that's available to be recovered from those lithium-ion batteries. These numbers might not mean a lot to you, but just to help drive home a point, which is just to help illustrate how significant this could be. Look at, for example, the lithium metal equivalent number in 2025. It's actually bolded and underlined there. See where it says about 40,473 tons of lithium metal equivalent. To give you an idea, in that year, that is equivalent to about 10 to 20% of the global forecasted demand for lithium in all applications. And today, there is no or little to no recycled lithium outside of us, and as far as we can see in the supply chain. Particularly lithium, there's been some cobalt, some nickel, but lithium has been an ignored material and hasn't really been recovered, which we'll talk about in a bit. So up from nil, basically 0%, to by 2025, potentially globally, this space being able to supply 10 to 20%, that is a big shift. And the point here is that big picture, this is really the shift towards urban mining. Right? So as we get materials out of the ground into EVs, into batteries, into the supply chain, and once they're above ground, the point is that we we can't lose it. These are critical materials. They have an impact, indeed, from sources when they get mined. And once it's above ground and can be urban mined, we have to keep it there. And we need technology that is going to enable us to do that. And via what we do and what this industry is doing and where it's going to, recycling could be not 10, 20% in the long term of the supply chain. It could be 50, 60%. Now I'm talking in a 20, 30, 40-year basis of the supply of these materials for the electrified economy. So this is a future I think we can all subscribe to, but it needs innovation, technology, commercialization, and an economic approach to really make this into a business. And that's what I'm going to really go to here as we now step a little bit closer to life cycle. And just to help, just from a macro perspective, just sticking there for a moment, just to help paint that picture more, there is a converse issue. So you have this waste, that's coming out of manufacturing and eventually end of life. The batteries, it needs to be recycled. Is a big opportunity for critical materials. You also have this feature where the market is going to be short of the supply of critical materials, say lithium, cobalt, nickel, relative to demand in the medium term and potentially the long term. And that's what these graphs are showing. So the gray line is the demand, the bars are essentially probability adjusted supply. So some that's existing, there's some that's expanding, there's some that's been announced. This is now mining and refining primarily. Some that will happen, some that may not happen. You see a big gap that appears into the late 2020s and into the 2030s. Part of that also is that, of course, not many companies have announced necessarily plans for 2030 to make metals. But the point is that this will continue to be a bottleneck. The supply of critical materials in the form that's needed for batteries will continue to be a tricky part of this whole electrification ramp. And the reason is that it's not, snap of the fingers, develop a mine and start producing chemicals. It takes time. These things have a lead time, and further, this is the tricky thing about it. Some of these, like cobalt, have sources that are not always ESG friendly. 65 to 70% of cobalt derives from the Congo, and there are some operators there that are good, sound, large companies that have very good standards, but there is a portion of that that has been traced to child labor. And this has become a really hot topic, rightfully so, for the battery supply chain, right? We can't be electrifying our future to a greener reality at the cost of human rights and human life, right? It's a very, that equation doesn't work, right? We can't all subscribe to that at all. So this is where recycling, now looking at a little farther on these graphs, right? I was talking about getting to 50, 60% of the total demand. Once we get it out of the ground in the cleanest and most transparent way that we can, we have to keep it. Right? We have to do the best we can to keep it in a circular loop, bring those materials back, get it back into batteries, and eventually wean ourselves off of what in some cases can be a net negative, right, from a mining perspective. And that's the future that we're moving to on an optimistic note. And I'm going to tell you about what do we do to help enable that. Just a brief comment, also in the space, it's interesting. We're seeing a lot of movement towards very forward-looking regulation around battery recycling. This is an example here from Europe. End of last year, they proposed a new battery directive update, which is basically going to be a regulation that dictates key aspects around battery recycling and traceability and carbon footprint. And I think one of the most forward-looking parts of this, just briefly, is a discussion around minimum recycled content in new batteries. It's the first time that's ever been tabled in some sort of legislation or regulation. And it's a powerful pull mechanism, right? To say, okay, well, battery makers, you have to use X% lithium, nickel, cobalt from recycled sources. Well, you need the whole supply chain to really get there. And that has a big benefit around carbon footprint reduction, big benefit around, as I was just talking about, getting away from these unsustainable sources of materials. So it's good to see. And Canada, Ontario, we have similar regulation that has been tabled. Still being developed in the direction of EVs. Some promises are quite forward-looking, but this as an example of regulation is something to look to. Okay, so I talked a lot about the industry and what's happening, and it's important because it helps to set the stage. Let's dive in now into, okay, how do we recycle batteries? What's been happening? What does life cycle do, and where are we going? I'm just watching the time, and I'll do this in the next, we'll make sure we leave about 15 minutes for Q&A, so the next 20 minutes. I'll look to go through this and then wrap up my part. So, starting with what's been happening with lithium-ion batteries before we came around, that's what this page is showing. And the real summary of this is that essentially batteries have been treated often like a waste, and they've been going into legacy infrastructure that recovers nickel and cobalt, and you have that in some battery chemistries for lithium-ion. And what's being shown here is eventually it gets to typically thermal operations. That is the most common tie associated with what's been happening with battery recycling. And 5 years ago, when we founded this business, coming from a metallurgical background, Tim and I were looking at this saying, well, that doesn't make any sense. When you put a lithium-ion battery into a high temperature process, you lose electrolyte, plastics, lithium goes into a solid waste stream, so you can't even get the lithium back. And if you try to, it's not even economic. You lose things like aluminum. And so by the time you add up the mass of a battery, it's well over 50% that's lost. And really these groups have been after cobalt, and cobalt is heavy in smartphone batteries and devices, not all, but most. But in electric vehicle batteries, there's not a lot of cobalt. Or higher nickel. And maybe folks are aware or not, but a lot of discussion around some of the issues I just highlighted about moving away from cobalt dominant chemistries. So this is what we were trying to add up in our heads was, how's this going to work, right? We're all going to get into electric vehicles, and then at the end of life, they're just going to go to high temperature processes, and then we're going to burn up the stack, things that we spent all this energy and resources and money to get into a battery form, and potentially generate harmful emissions in some cases, and not get back the majority of the materials. It doesn't equate, right? It doesn't add. So that was why we founded LifeCycle. This was one of the biggest reasons. Frankly, it was a frustration for Tim and I. And out of that is born opportunity and innovation. So this is what we do. LifeCycle runs a two-phase process. And there's a few more pages with a bit more depth in this as well. So let me explain this. We run a spoke and hub model. And what is that? Okay, so spokes are regional facilities that take in any type of lithium-ion battery, small to large, cell phone battery, mobile phone battery, all the way to electric vehicle pack. And we reduce the size, we mechanically process into intermediate products. And the picture on the left is actually of our Rochester plant, which is commercially operational. That's our second plant that does that in North America. The first is in Kingston, Ontario, Canada. And we get into intermediate products. So think of this like the dough to the pizza. It's like an intermediate form. And okay, why do that? Why split things up this way? Well, when we were developing the business back in 2016, 17, 18, earlier days, listening keenly to the customer. And the customer is, in this case, electric vehicle manufacturers, battery manufacturers, groups that collect and sort these types of batteries. And one of the first things always highlighted is logistics. It's where the battery is going and what's the process associated, but it's also, hey, like if you're a company that has batteries to be recycled, the first thing you face is I have to ship the batteries to you, and typically the shipper bears the cost. And that's a potentially costly activity. So how do you bring that down? How do you bring the footprint of that down, the cost of that down, get closer to the customer? So that's why we split up this part of the business into the spokes. I can tell you this has been very enabling. It's enabled us to get to scale. These are low capital cost facilities. We now have 2 of them. We've announced a 3rd in Arizona in the US, and we have a global plan to build 20 in the next 5 years. And we are well on our way with many of those facilities. So network of spokes, get an intermediate product, and then it's centralized at what we call the hub. And the hub is where we take in the cathode anode material, which is really where you have a lot of the value. That's where you have your cobalt, your nickel, your lithium. So the really critical materials that I was showing previously. And at the spokes, we separate out the plastics and the metals, and we sell those back to the economy. We do this with no wastewater. We do it non-thermally. It's a super important point. And then at the hub, what we do is we convert that cathode anode material back into lithium ion battery chemicals. So back into lithium, nickel, cobalt, and more. And those are essentially the urban mined equivalent of what would come out of a mine and refinery. So end to end here, what have we done? What we've done is we enable much more sustainable battery recycling from an environmental perspective, nothing thermal, no wastewater at either step. We've engineered that way. No solid waste out of the key products, which is very important. So as long as we have a big tailings or waste stream. And by being non-thermal, we're not generating lots of emissions. But conversely and economically, we are doing this because we want to unlock the value from batteries. We don't want them to be treated as a waste. The key thing here is get out the core critical materials, totally agnostic to the battery type, and not just cobalt, as was the historical focus, but also the lithium, and more of the nickel, and more of the cobalt, and manganese, and more. So what that enables is profitable battery recycling, and the effect of that on an EV driver, ultimately, is no cost that will be borne and passed on to the consumer for battery recycling. That's super important. And secondarily, we can produce these materials cheaper than mining and refining because we start with a very rich source. We're not digging things up out of the ground. It doesn't cost a lot. And we have all these materials we're getting from one set of facilities. So we're cheaper than a mined and refined material. But that then means that we can be cheaper for batteries. Critical materials are one of the biggest cost components in batteries. And long term, that's what we're going to enable is cheaper batteries, cheaper electric vehicles as a result. And again, a positive feedback effect of proliferating more electric vehicles. So there's a lot of info, and I know I'm going to cover more in the Q&A, but I wanted to get to the meat of what we do, of course. And here are some photos to help give some added context around that. So this is our Spoke 1 in Kingston, Ontario. It's our first Spoke facility. Again, here's where we take in batteries and we go to intermediate products. This is patented, owned by the company. We fully developed both these processes, the Spoke and the hub. And this is the first facility. We take in 5,000 tons per year of lithium batteries. We do this commercially today. We have 50 plus battery customers, as I mentioned. We make product, we sell product, and I'm going to get to some of where that goes in a bit. Here's the second facility in Rochester, the second Spoke. You might note a bit of a visual difference. See also there's these blue frames and the yellow, just a bit of a different visual feel. Same process. What we did here was we have this global plan for 20 spokes, as I mentioned. And we see that's really critical here is our replicability, being able to build these very quickly and consistently. And as I mentioned, we want to build a total of 20 of them around the world. So we actually have modularized the process almost like Lego blocks, where we build this all together. It is tested, factory, accepted and tested in one place, and then we ship the whole plant down or to wherever it's going together. And to give you the case study of Rochester, we shipped down the plant on November 3rd of 2020, and we were commissioned by December 4th. So now as we're looking to additional spokes in Europe and other places. Again, people want speed, right? If there's a need, you have to get going, you have to set up quickly. So this allows us to do this very quickly, replicable fashion. And because the facilities are non-thermal, we can deploy these very easily with very efficient permitting. If you're doing something like a high temperature process, which is not what we do, big issues around permitting. And from an environmental perspective, this is very positive, right? People, it's close to your house or an industrial area, but close by to folks. There's no NIMBY effect, right? Not in my backyard effect, because it's safe, it's clean, there's no wastewater, there's no air emissions that are toxic, and all the products that we make go back to the economy. So good environmentally, good economically. And now to the other part of what we're doing. I mentioned the hub. This is a 3D rendering of the larger facility. So we build 12 spokes to every hub. We have announced that we're going to be building this in Rochester, New York. Why Rochester? It's the former Eastern Business Park, or the Kodak Business Park. So great chemical infrastructure, great labor pool, strong support from the state. So very amenable for this style of operation. It's a wet chemistry operation. So again, non-thermal. We have about 45 people working on this right now. You see some of the timelines at the top here. So we're going to be breaking ground here, targeted by the end of the year, 2021. We're well in execution, and the intent is to be built and ramping up towards the end of 2022 and early 2023. So the intent here is that we've taken the intermediate product from the spokes and we go back to the finished battery grade materials. And that's what these are. So I always like to show these because they're very brilliant colors. These are actual things that we've produced. So just to walk through what they are, so you have lithium carbonate, nickel sulfate, cobalt sulfate. These are the actual chemical forms of what goes into a lithium ion battery material. So cathode, which is what goes into a cell, and then into a pack, ultimately, that goes into a vehicle. It's right back to that kind of top of the supply chain, akin to what is produced out of mining and refining. And so what we've been able to demonstrate here is, we built a large-scale demo hub. We ran that. That was before we decided to go to, just going to go back a slide for a moment, this larger facility, which is a much larger capital investment. And we did that consistently with different battery types, coming back to these fundamental chemicals and proving, because I think one thing, just as a big picture comment, people might say, hey, how do we know that these are going to be the same quality as a virgin material? And the point there is that we're going back to the fundamental atoms, and then we're remaking the chemical. And that's where the technology comes in and the patented aspects of what we do. But the essence of it is that we go back to battery grade materials. So these have been qualified, tested, and we have a key offtake partner. Their name is Traxys. They're the largest independent nickel cobalt trader in the world, but they've signed offtake or a sales agreement for the end products with us because of the testing and the qualification of these materials to be deemed and ensured that they're suitable to go back into battery applications. So this is a big deal. I think people, when they think recycled material, they might think of recycled tires or plastics, where there's a lot of innovation, but sometimes materials aren't suitable to go back into the same application. Here, because we're going down to the fundamental building blocks, so the fundamental atoms of lithium, nickel, cobalt, and more, and then rebuilding them, that enables these materials, in a refined form, to go back into lithium-ion batteries again. Back to my big picture premise. Once we have this in the above ground mine, to not lose these materials and ensure that they stay in that loop above ground for as long as we can, so that we can ultimately here offset the amount of material that needs to be mined and refined. So that's the path that we're on. And like I say, the supply chain and customers are very, very keen about this material. And obviously we have a key offtake partner, Traxys, but even the folks that use the product downstream of them, there's a lot of desire for recycled critical materials. So I think I did pretty okay on time there. I'm going to wrap up here on the last slide, and then we'll open up for Q&A hereafter. But just to help conclude the presentation portion here. So just to touch on some of the things I talked about. So one, from an industry perspective, lithium-ion battery recycling is not something for 10 years away solely. This is not something that grows solely at lag with the proliferation of lithium-ion batteries in electric vehicles. In fact, this is an industry that needs to grow in lockstep with the building of batteries, which generates production waste, and to already deal with other types of lithium-ion batteries that are in our everyday lives as phase one, and as phase two, to be prepared then for the ultimate tsunami, the proverbial tsunami, of end-of-life lithium-ion batteries that will come in the future from electric vehicles and other electrified mobility and broader applications. The second point here is that historically, battery recycling has needed a lot of innovation. And you can tell, right? Lithium-ion batteries commercialized in 1991. The recycling industry, in itself is not that mature, right? Up until new companies like us have come along. And hence, what's been existing has been what we would deem non-fit for purpose types of recycling or processing, treating lithium-ion batteries as a waste, and unfortunately not really unlocking the value and not really fit for the future of an electrified transportation economy. So that's been really a high temperature processing approach. And point three is what Lifecycle is doing as a case study is we've innovated, developed technology, it's patented, but the essence of it is, and the core tenets have really been around environmental and economic sustainability to really drive here much more efficient recycling. We have a big opportunity and a big gift, if you will, from the starting material that it's very valuable. These are very refined materials that have taken a lot of energy and money to get into a lithium-ion battery. So the starting point is great. What is then needed is the innovation to make that work in a safe and in a environmentally friendly fashion and in a very efficient fashion. And that's what we've tackled with our spoke and hub model. And I think the point here from an EV driver perspective, just to close, as I open, lithium-ion batteries will not go into landfill. That is a big misnomer, and because they're valuable. And there is innovation as we're driving here to really ensure that we capture the value out of that. And long-term, from a consumer perspective, the benefit of this will be cheaper batteries and cheaper electric vehicles. As we get materials out into the above ground mine, the urban mine, we will endeavor to keep them here. And that will ensure through technologies like this and the infrastructure we're building that we continue to reintroduce them back into new batteries to diminish over time the amount of mined material, but also to drive cheaper, more accessible, and more ubiquitous electric vehicles. So thanks for having me. I look forward, and see there's been a lot of questions coming in. Looking forward to chatting through them.
Thank you, Jay. That was terrific. Yeah, there are a lot of questions, and I'm not surprised. I think you struck a nerve with this audience. Loved hearing that. So, Jason, would you mind taking us through those?
No problem, Tim. We'll get started with hopefully an easy one. When harvesting the battery, how in general does the process handle the residual charge of the battery in a safe manner?
That's a great question. So I'm going to show the picture of the Rochester spoke, for example. So I can answer in two parts. So first, what's been happening before we came along, this is now getting a little more detailed in the process, but just briefly. So say you had an EV pack and maybe it comes back to a dealer or a showroom and maybe there's a problem and something's replaced, and then now you have this old pack or battery, and even down to like a cell phone battery, for example. So there is typically residual charge, and in a large pack that can be a lot of energy, right? So what would happen in a typical, say, historical context is Other groups have, other recyclers that have existed have discharged those batteries manually. And I've seen physically in other facilities, large packs being thrown into brine baths, so basically a salt bath, which then results in the charge being dissipated, but that generates toxic emissions as well, potentially because of gases. And it's not very safe for people to be handling. I've also seen batteries being hooked up to big resistor banks, which is very manual and again, potentially unsafe. So we identified this when we were doing our work in innovation on the spoke side. And what struck us is we're also now getting way more batteries, and scalability is really important. And if you have a step like that where you're brining batteries, so throwing them into a brine bath, or you're trying to manually discharge the energy, which takes a long time and space and equipment, that becomes a bottleneck. And as we need to scale, and scalability is very important here, and we have, you don't want that to be the case, right? That becomes a single point of failure. So point two is, what we do is actually, we've innovated in the spoke process mechanically that it's a shredding process. And the way that we do that, which is patented, we can we can feed fully charged batteries into the process and safely size reduce them. And the way that we do it, just briefly, is submerged. So that's what's encompassed in our patent. It's in numerous patents that surround that as well, which deprives the system oxygen and absorbs energy. And then there's some other aspects to that, which I won't get into. But this safety is a huge, huge focus all along the chain. Within the process, we've inherently eliminated that risk. But even before, in the handling, the shipping, the storing, we've had to innovate and operationalize, and we're ISO certified as well to underpin that, to really handle that challenge. And that's what we're doing now, and we continue to try to lead in terms of the standards and the approach.
Okay, thank you. This next one may or may not be appropriate for your business, but what are your plans to repurpose the batteries from vehicles to residential use?
So we don't repurpose lithium batteries at Lifecycle. We do work with groups that do that. There's the concept of the 4 R's. The 4 R's are to repair, remanufacture, refurbish, and repurpose. In some of that case, it could be out of an EV pack being refurbished back into an EV pack. We've seen that. All the way to what was just asked about, which is repurposing into, say, home storage. So we work with groups that do that. We've chosen to keep our focus on the resource recovery. And when they repurpose in that fashion, they actually have fallout of battery modules or cells that are not suitable to be reused. So we get those from those groups already, along with batteries that are not suitable for repurposing as well.
And I think that's a very good point for the audience. When batteries are finished and no longer fit for one purpose, they may very well be useful for another purpose. We see lots of examples where an EV pack is no longer containing enough charge for an EV driver, but is perfect for stationary storage in a home or a business. So they don't have just one destiny. They can have multiple lives before being, reaching you for recycling. The next one is, what happens to your business when battery chemistry changes? Example, solid state.
Yep, good question. I'm looking through the questions here alongside. So just going to go back to our general spoken up. So the short answer is we're very close to the battery industry in solid state. We actually already today get solid state batteries, interestingly enough, and where we get them from is this R&D scrap. So we have some groups that are doing research and development into solid state, and we already see them as part of our spoke facilities. In short, we actually like solid state batteries. There's no real changes to our technology. Why we like them is because they don't have the liquid electrolyte. We deal with the liquid electrolyte in a certain fashion, and we recover it through our spoken hub, but it's tricky. And we've had to innovate how to deal with that. In a solid state battery, that's the essence of it, right? You don't have a liquid electrolyte. And also there's more recyclable material because there's more, depends on the type of solid state, but if it's a lithium metal anode, there's more lithium content per battery than a usual lithium-ion battery. So the actual recoverable material is higher. So we actually like solid state batteries, and we see them today already.
Okay. Next one is, who are your customers for recycled battery materials?
Yep, so I'm going to show the 3 lithium carbonate, cobalt sulfate, nickel sulfate again. And so I talked about here Traxys as a key off-taker. They are, you know, $6 or $7 billion a year turnover business. So what they do, just to help explain a little bit more. So they are specialists in battery materials. They are the buyer from the North American hub. It took time to make the product, qualify the product, validate the product, which then led to the qualification and then their offtake. They're actually also an investor in the company. And so from a big picture perspective, you know, we're executing a lot here. We have spokes, we're building a hub. We know these markets, but we're not traders, right? And one of the things we try to pride ourselves on is always identifying where we need to bring in partners or additional acumen, and that's what we want to do with Traxys. So they're the buyer. What happens then downstream of them is these materials go back to either cathode makers or cathode precursor makers. So that's ultimately the supplier back to a cell. And we can allocate collaboratively with Traxys in terms of where material goes, which is important because what's happening is increasingly, if I just go back to the spoke, just to show you a picture of that, the batteries that are coming in here, we get many, many sources in, 50 plus customers. What's happening increasingly is some of those customers are saying, hey, eventually can you supply back the materials as well? And so it's important that we can, you know, allocate and try to redirect back in the supply chain as these quantities come up on the battery end. And with Traxys, we have that flexibility, but it helps to de-risk our plan because we have the buyer essentially of our end products.
Okay. The next one is a little longer. Are you familiar with First Cobalt Corporation of Cobalt, Ontario? They're going to have a plant operating, that would have been last year, separating cobalt from mine tailings using renewable electricity.
Yep, we are, and we know that team actually fairly well. So that is, you know, you'll be taking primary material, and you know, this is public information, I think, was alluded to in the question. You know, they're also talking about potentially taking recycled material in and to make cobalt. Big picture, you know, what is happening in this space, and I just pulled up our 3D rendering of the hub here to help contextualize. What's happening is you basically have pre-processors of batteries that have been around, and some are popping up, that take batteries and go to an intermediate product. We do that in our spoke fashion, which is more efficient, cheaper, more scalable, much more environmentally friendly. But there's others that have been around for some time in Europe and other places doing that thermally and, you know, other fashions. But everyone kind of gets to the same, you know, range, if you will, of intermediate product. And the term for that, I didn't use it in the presentation, but it's called black mass. Black mass is the cathode anode material from the battery. So what they're talking about First Cobalt is taking potentially black mass and going back to refined battery materials or mixing in with primary material. You know, there is a need, I'll say, in the market robustly. There is a shortfall of the, we call it refining capacity, or the hub capacity in our case, relative to the pre-processing, and that's why we're going in the direction, is a big reason, to our hub in Rochester. What I will say is, you know, we'll speak to specific parties here, but the general issue that's been there in the market is you have all types of lithium-ion batteries, just a brief comment, and it's hard to differentiate to say, okay, hey, we only want, say, high cobalt black mass, or we only want purely high nickel, like a specific chemistry. It's very variable. Lithium ion is a very big family, and the technology needs to be able to deal with that variability. And so that's how we're centered. And even if there's a non-cobalt containing lithium battery chemistry like lithium iron phosphate, that's what Tesla is going to be going to in their $25,000 vehicle, and VW's also talked about. We're totally agnostic. So that's going to be a very key thing in terms of the bigger picture aspects that I talked about. And so we'll see as others, come up and see how they participate. But that's the way the market is structured and where the need is.
Hey, Jason, I think we can squeeze in one more quick one.
Okay, this is the next one up. You touched on where your existing plants are located, but it sounds like you have pretty substantial future growth plans. Can you expand a little bit on kind of the locations you're thinking of expanding to?
Yeah, and just briefly watching the time. So yeah, global plan is 20 spokes and 4 hubs. So I have touched on where we are existing today and where we're going in the near term. We have a plan which spans between Europe as well as APAC, Asia Pacific. The way that we're doing that, just briefly, is 3 ways. The first is via partnership. So we have boots on the ground in Hong Kong and China and Korea, Japan, as well as in Europe, in various places. So for the past 2 years, we've been essentially funneling in partners that have batteries that need to be recycled, or they're participating in the supply chain in some way. And what we can bring to the table is the technology, and do that through, for example, joint ventures or other forms of partnership. So that's the first way we're rolling out, and there'll be more news around that in the coming months, quarters ahead. Second and third, what we are finding is existing customers we have that are global in nature, they are starting to say, hey, Lifecycle, you're serving us in North America. We have a need over here in, say, Europe or elsewhere. Can you please come help us? So that's an impetus to basically set up organically. And the third is judiciously, we do see opportunities for some buy-side M&A to acquire potential regional players. This is where they have supply, people, permits, good facilities potentially, but lack the technology. And we can come in and help to bolt on what we do, to do it more efficiently. And that again is an opportunity for us to roll out with those 20 spokes and 4 hubs. So we have some public information out there on where that is intended to be, but all I can say beyond that is just stay tuned for more news to come.
Okay, thank you very much, Ajay. I will hand things back to Tim at this point.
Thanks, Jason. Thanks, Ajay. Well, that was absolutely fantastic. You know what? A lot of us drive electric cars because we believe so passionately that they're great for the environment. And you've just shown us that. By the way, the landfill remark was not mine. I'm just want you to know that's what we hear often out there. I absolutely realize that these things aren't going into the landfills, but you certainly put it into that. And thanks also for giving me another word for my vocabulary. I mean, urban mining. I love that. That's going to be. I'm going to use that all the time. That's such a great encapsulation of what it's about. But yeah, and it's really encouraging to see a new industry emerging in the wake of large scale electrification. And to know that it's that disposal of our batteries at scale can be done effectively and profitably. It really makes this major EV component sustainable, and what a fantastic thing. I wish we had more time. There were a ton of questions there. I may circle back to you and ask for a little separate meeting, just a small group of us to go through some of the questions we didn't get to when we have a look at them. And I hope that you might be kind enough to spare a little more time for us to do that. But thank you. That was really wonderful. I appreciate the time and all you've done for us here tonight.
My pleasure. I'd say there's a lot of questions. Sorry we didn't get to all that, but happy to follow up as needed, and looking forward to the conversation ahead.
Fantastic. And thanks, Jason, as always, for getting us through the Q&A. And really thanks to the whole webinar team for their help with tonight's episode. We hope that you in the audience will come back for the next episode of Canada Talks Electric Cars, which will be on June 1st, same time, same channel. Our guest then will be Ted Dowling, who is VP of BYD Canada, who will be talking about medium and heavy duty EV adoption. So another source of batteries for Ajay. Ted's focus will be on the Canadian commercial EV business, from buses, trucks, delivery vans to taxis. The impact on our greenhouse gas reduction goals and how it has driven change in the consumer market. So it should be a really interesting talk. Thank you all for joining us for this month's webinar episode. Love having you all here. And from all of us at the Electric Vehicle Society, and until next month, please stay safe, stay healthy. And this concludes tonight's webinar.